As we talk, the nighttime sky is present, undergoing profound changes that could remodel its look within many years, if not sooner. Professionals, astronomers around the sector have raised the alarm. Personalities such as Neil deGrasse Tyson have collaborated that Polaris is about to undergo a drastic trade, and the story behind this occasion is traumatic. Polaris' important function within the night sky has defined ESP specialty as a North Star. Till now, this megastar became a constant reference point for stargazers, navigators, and astronomers. But this stability may want to soon be altered, notably transforming both our nighttime sky and the astronomical measurements we're accustomed to. Join us to recognize the seriousness of this risk and its impact on all of us. Let's examine the history of Polaris, which is in its final stages. Polaris has long been considered the guiding star that leads the manor, a beacon revered by astronomers and navigators throughout the centuries. Its constant presence in the firmament has been essential to celestial navigation, but all this can change. A latest have a look at offered by way of the reputable Royal Astronomical Society in September 2023 has raised uncertainty approximately the future of this bright star. Polaris is on the verge of an explosion that will cause it to vanish permanently from the night sky. Before we delve into the implications of this revelation, let's take a more in-depth look at the star in query. Polaris, also known as the North Star or the Pole Star, occupies a special role in the sky due to its proximity to the celestial North Pole. It is nearly immediately over the Earth's North Pole, which gives the illusion that it remains static in the northern sky. The star is located within the constellation Ursa Minor. Polaris is a star of moderate brightness that stands out as a yellow-white giant of significant size compared to our Sun. Notwithstanding its appearance as a lone star, it is actually part of a rather complicated triple-star system. Within this system, the primary stars are Polaris AA and Polaris AB, which to the bare eye appear to be a single star. In addition, there is a third companion, Polaris B, orbiting this binary pair. The gravitational forces among these stars shape their orbits and influence their individual behaviors, which has a direct impact on their brightness and other notable traits. Any disturbance in these interactions can cause irregular modifications in stellar luminosity or pulsation patterns, but we do not yet fully understand the exact details of these processes. Polaris is about 323 light-years from Earth, meaning that the light we receive from this star today was emitted 323 years ago. This notable distance means that if Polaris were to blow up today, we wouldn't be privy to it until 320 years later. Consequently, when we eventually witness this event from Earth, more than 3 centuries would have elapsed since it occurred. The scientific projections are based on empirical evidence available at present, which suggests that it's possible Polaris has already experienced an explosion, but we have not yet received the light from that event. Throughout history, the North Star has played a significant role extending through various civilizations and eras. This star has acted as a lighthouse, permitting specific orientation and navigation in seas and lands. Located nearly in step with the Earth's axis of rotation, it stood as a reliable reference point for determining route, especially in the Northern Hemisphere. The North Star holds great symbolic importance in all cultures. In some social groups, it represents the concept of constancy and solidity, perceived as a pole star and an element that has remained unchanging amidst the celestial ballet that makes up the night sky. Recently, this star has exhibited behavior out of the expected. This disturbing alteration in its pulsational cycle has prompted astronomers to further examine this celestial anomaly. Instead of following the predictable pulsation pattern, Polaris has adopted an unpredictable and erratic cycle of dimming and brightening. This change has raised concern among scientists who warn that the star may be nearing the end of its life. This variation is consistent with the behavior observed in stars as they approach the end of their life cycles. The recent growth in the pulsation period of Polaris, which was previously stable in its dimming and brightening cycle, can be attributed to interactions between the stars in the system. Though perceived as a single entity, we have observed an unusual increase in pulsation period of about 45 seconds. Although seemingly insignificant, this transformation is of significant importance. Some astronomers have cautiously suggested that gravitational forces between the Polaris stars may be the cause of these fluctuations in the star's atmospheric conditions, directly affecting its pulsation patterns. However, Others firmly believe the star is near its explosion. This suspicion is based on the striking similarities between the mysterious behavior of Polaris and Betelgeuse, another prominent star in the Orion constellation that has shown puzzling alterations in brightness, prompting speculation about a possible forthcoming explosion. Several experts have warned of the star's inevitable end, emphasizing abrupt fluctuations in its brightness and behavior patterns similar to those of stars that have reached the end of their life cycles. NASA was attracted by the anomalies presented by Betelgeuse. The organization has shown significant concern about the possibility of Betelgeuse exploding, which contrasts with the irregularities observed in Polaris. Though NASA has expressed strong interest and vigilance toward the unusual behavior of Betelgeuse, it has not made any professional declaration or comparable monitoring concern regarding Polaris. These stars undergo an in-depth journey through different stages of their evolutionary cycle. When new, these stars have extremely low temperatures and brightness. Eventually, they advance to the main sequence phase marked by nuclear fusion, where they remain stable for billions of years. Finally, as their hydrogen fuel is depleted, they enter the red giant phase, experiencing a rapid increase in temperature and brightness. This phase sees a dramatic increase in energy output before reaching a catastrophic explosion. If Polaris were to experience a supernova, we would witness an extraordinary event in our sky. The star would become highly luminous, potentially eclipsing even the brightness of the moon and becoming one of the brightest objects in the nighttime sky. This luminous spectacle could last for days, weeks, or even months. The star's visible appearance would undergo drastic changes, transforming into a dazzling point of light or a brief luminous object, potentially manifesting colors before fading. This visual display could momentarily alter our familiar perception of the constellations Ursa Major or Minor, since Polaris is actually the North Star and is part of these stellar groupings. As for our safety, we would be completely safe. Given the size and distance of Polaris, it is unlikely that Earth would be affected, even in the event of a stellar explosion. Visually, although a Polaris supernova may not be as spectacular as Betelgeuse, it could be visible to the naked eye for a long duration and outshine nearby stars. Furthermore, the implications of Polaris' potential supernova extend beyond its visual impact. Such an event would also have significant implications for astronomical observations and measurements. The sudden burst of light and energy from a supernova could provide astronomers with invaluable data about the dynamics of stellar explosions, the formation of heavy elements, and the evolution of galaxies. It would offer a unique opportunity to study the aftermath of such a cataclysmic event and its effects on surrounding celestial bodies. However, the uncertainty surrounding Polaris' future adds complexity to our understanding. Astronomers continue to monitor its behavior closely, analyzing data and refining models to predict its fate more accurately. The irregularities observed in Polaris pulsations challenge existing theories and underscore the dynamic nature of stars even in their seemingly stable phases. Beyond its scientific implications, Polaris holds cultural significance as a symbol of guidance and constancy. Its potential transformation or disappearance from the night sky would mark the end of an era, affecting not only astronomers but also cultures that have long relied on its steady presence for navigation and symbolism. While Polaris' future remains uncertain, the ongoing study of this celestial phenomenon provides a glimpse into the complex and ever-changing nature of the universe. Whether it continues to shine brightly as a guiding star or undergoes a spectacular transformation, Polaris will continue to captivate our imaginations and inspire further exploration into the mysteries of the cosmos. The study of Polaris and its potential supernova event also raises broader questions about the nature of stars and their life cycle. It prompts us to reconsider our understanding of stellar evolution and the factors that influence the stability and behavior of stars over time. Astronomers will continue to observe Polaris with advanced telescopes and instruments, seeking to unravel the mysteries surrounding its current anomalies and future prospects. Moreover, the potential impact of Polaris supernova on Earth's environment and atmosphere is a topic of scientific inquiry. While the star's distance suggests minimal direct effects, the event could still contribute valuable insights into cosmic radiation and its interaction with our planet. From a historical perspective, Polaris has been a beacon of navigation and cultural symbolism for millennia. Its sudden change or disappearance would not only alter our astronomical perspectives but also resonate deeply with cultures worldwide that have woven its presence into their myths, navigation practices, and spiritual beliefs. In essence, the story of Polaris is not just about a star in the night sky. It reflects humanity's enduring curiosity about the cosmos and our place within it. As we continue to monitor and analyze Polaris' evolution, we deepen our understanding of the universe's dynamics and our connection to the celestial realm. Whether Polaris fades quietly or erupts spectacularly, its journey continues to illuminate the paths of scientific discovery and cultural heritage alike. The ongoing study of Polaris and its potential supernova event underscores the dynamic and unpredictable nature of stars. This exploration extends beyond Polaris itself to encompass our understanding of stellar physics, evolution, and the broader implications for astronomy. One of the key areas of interest is how Polaris supernova could contribute to our knowledge of cosmic phenomena such as neutron stars and black holes. Supernovae are crucial events in the life cycle of massive stars, leading to the formation of these exotic objects and dispersing elements crucial for the creation of planets and life. Additionally, Polaris transformation would provide a rare opportunity to study the effects of a nearby supernova on our galactic neighborhood. Scientists would analyze how the sudden burst of energy and radiation impacts surrounding stars, gas clouds, and even distant planets, shedding light on the interconnectedness of cosmic events. From a technological standpoint, advances in observational techniques and computational models are enhancing our ability to predict and understand stellar behavior. By monitoring Polaris and similar stars with precision instruments, astronomers can refine their understanding of how stars evolve and the factors that drive their variability. Beyond the scientific implications, Polaris' potential supernova captures the imagination and curiosity of people worldwide. Its story serves as a reminder of the vastness and complexity of the universe, inspiring wonder and contemplation about our place in the cosmos. In conclusion, the exploration of Polaris and its possible future as a supernova continues to be a journey of discovery and inquiry. It invites us to delve deeper into the mysteries of stellar evolution, cosmic dynamics, and the enduring connections between science, culture, and humanity's quest for knowledge. As we continue to unravel the secrets of Polaris, we advance our understanding of the universe and our role within it, forging new pathways of exploration and understanding for generations to come.